These are the blood vessels that bring blood back to the heart, and you can see there's a lot of them. Once again, these are not even all of the veins that are part of your body, but the veins that you need to know from this lecture that you're responsible for the end of unit exam are here. So we're going to start down here at the bottom. You've got this major vein running along the medial side of your leg, and that's called the saphenous vein, and that's spelled for you right here. And then you also have this vein here running up the like the anterior side of your leg, and that's called the femoral vein, and it's called that because, you know, this is the femur. So these veins bring deoxygenated blood from all of the cells that make up your leg into the iliac vein. So the iliac vein, right here and right here, drain into the inferior vena cava, going up this way, which then drains the deoxygenated blood into the right atrium. At the same time, you also have the brachial vein, which is right here. It's also shown for you, I'm sorry, right here. It's also shown for you right here. And you have the cephalic vein, which is superior to the brachial vein, or more lateral to the brachial vein. And so the brachial vein and the cephalic vein, which, by the way, the median cubital vein, or just the cubital vein right here, is going to connect blood that's draining from the lateral part of your arm and blood draining from the medial part of your arm. But the point is, all of it is draining into the brachiocephalic vein right there. And remember the prefix brachio, which you can see spelled here. So the prefix brachio means arm. The suffix cephalic means towards the head. So the brachiocephalic vein is the part of the brachial veins that is closest to the head. And then here you have another brachiocephalic vein. Now also draining into the brachiocephalic vein is the jugular vein right there. So you have all of the deoxygenated blood draining out of your head and face and neck into the jugular vein, which then drains into the brachiocephalic vein, which then drains into the superior vena cava, which then drains into the right atrium. Here's an overview of veins. So they do bring blood back to the heart. And at this point, the blood has traveled through the arteries, through all of the arterioles, through the capillaries, and you've lost a lot of oxygen and some water as well. So by this time, you actually have less blood flowing through your body, relatively. And it's also at much lower pressure because the ventricles were the ones that pushed the blood out of the heart. And so by the time it's coming through the veins, it's much farther away from the heart. Also, the veins do have thinner walls, and that's primarily because the tunica media, right here, sorry, this part, the tunica media is so thin. And so since the blood pressure is so low, the lumen of the vein is going to be much larger than it is in the artery, and that's to ensure that there's balance of blood flow compared to what you find in the arteries and the veins. That being said, because you're at low pressure, first of all, and second of all, because so many of your brains have to bring blood back to the heart against gravity, right? Think about the majority of your blood vessels are below the heart, and they have to bring blood up, back towards the heart. But gravity wants the blood to drop down back towards your feet. And so in order to prevent that from happening, you have these things here, these valves, and they point in one direction, and that's back towards the heart. So blood flowing this way will open the valve, but if blood tries to go back, that will close the valve. On top of that, you have skeletal muscle that's external to the veins. That's also helping blood to flow in one direction. So remember, you have smooth muscle right here in the tunica media. And on top of that, you have skeletal muscle, the striated muscle, that's surrounding the veins, especially the larger ones. And so when the skeletal muscle contracts, it pushes against the vein. That creates an area of high pressure right here, which forces the blood up and out through the valve. It also creates an area of relative low pressure behind where the muscle contraction happened, which then allows the valve to close even better. And then also, when you breathe, your lungs will expand, which then creates pressure, negative pressure, which pulls blood back towards the heart as well. Okay. So as long as you're young and healthy and things are working the right way, then this is how things should happen. Blood should only flow in this direction, back towards the heart. If the blood tries to flow back downwards, then the valves should close, preventing that blood flow from happening. That being said, some people will experience what's called valvular incompetence, and when that happens, you have what we call a varicose vein. It looks like this. So what's happening here is the veins are becoming enlarged and they're becoming twisted. And that's because the valves have become incompetent. And so since the valves are no longer closing all the way, blood can flow back down. Now you have blood flowing up and you have blood flowing down. So you have extra blood that's accumulating in these veins, which then stretches the walls of the veins. So they become larger. And because the veins are carrying deoxygenated blood, that blood is darker. So it's even easier to see those veins. And on top of that, because the veins are right underneath the skin, for reasons that we'll talk about later on in this unit, not in this lecture, they're even easier to see. So they bulge out of the skin like this. And then on top of that, if you have very pale skin and or if you have a lot of pigment in the walls of your veins, usually because of genetic reasons, then they can make these like spider-like bluish or greenish or purplish lines that crisscross along your legs. So why does valvular incompetence, also called varicose veins, why does this happen? A couple of reasons. The main one is genetic. So if you have people in your family who have varicose veins, you're at much higher risk of getting varicose veins yourself. But the second is lifestyle, and that's primarily a function of your career. Are you in a career, because most people keep the same career or they go into similar careers over decades. So are you in a career where you are standing for long periods of time, like standing still? Or where you're sitting down but you're sitting improperly. So, for example, let's say that you are in an office chair and your feet are not properly supported, and on top of that, maybe you're crossing your legs, or maybe you're wearing, like leg, um, like hose, or what are those called? It doesn't matter. Let's say that you're wearing socks or whatever that are not properly supporting blood flow through your veins, then that can promote valvular incompetence. Or if you're standing still a lot, then once again, blood is trying to go back down towards your feet, and that can promote valvular incompetence. If, on the other hand, you're really active, like let's say you're walking or you're running, or you find other ways to get up and get around, when you promote blood flow, then that actually helps blood to flow through your veins back towards your heart, and it can prevent varicose veins from developing. So the moral of the story is, if you're in a career where you're standing or sitting for long periods of time over decades, exercise becomes even more important. And so does things like not smoking, because smoking can also promote the formation of varicose veins. All right, so to wrap up this lecture, let's compare and contrast arteries, arterioles, capillaries, venules, and veins one last time. Here in this graph, you can see a comparison. These are bar graphs, so you can see a comparison of the relative thickness of the tunica intima, which is the endothelium, any elastic tissue that might make up the tunica media, smooth muscle that makes up the tunica media, and fibrous tissue that makes up the tunica externa. And so you can see for arteries and arterioles, venules, and veins, they all have, all five of these blood vessel types have the endothelium that makes up the tunica intima, right there, right there, right there, right? So they all have a tunica intima. On top of that, arteries, arterioles, and veins all have smooth muscle that make up their tunica media. But look at how the arteries have a lot more smooth muscle, and the arteries also have a little bit more elastic tissue to support proper blood flow through the arteries away from the heart. Sorry, one more thing. Also, once again, notice the size of the lumen of the vein compared to the size of the lumen in the arteries. Here you guys can see that again. Here's an artery. Right next to it is a vein, so you're looking at a cross section. And you'll notice the lumen is much larger here, but the wall, the tunica media, is much thicker here. And then last of all, you can see a comparison of the direction of blood flow in arteries versus in veins. Okay, at this point, I probably have asked you to do some sort of compare and contrast between arteries and veins, and so I'm going to leave you with this, and I will see you guys next time I see you.